Hey everybody, how's it going today? I'm going to teach you a little bit about how to balance a chemical equation. This is Mr. Yago here. I'm going to just kind of run through the basics. Here we have a chemical equation. On the left side of this arrow, we have our reactants. So as you can see here, we have Fe2O3 plus carbon. So iron oxide plus carbon is going to yield or make, which basically means when you mix these two, this compound and this element together, it's going to make raw iron, which is by itself, as well as carbon dioxide. And what's right of the arrow, what is yielded or made, is considered the products. Now, there's a couple of things that you are going to have to know in terms of terminology. Number one, right here, this is considered a subscript. Okay, so subscripts apply directly to this element. So we have, in this case, we have 2 iron and we have 3 oxygen. If there isn't a subscript, we assume that there's just 1 there. Okay. This 2, however, only goes to oxygen, not carbon. All right. So one of the things that I like to do is I like to look at all of the elements that exist on the reactant side and compare it to the product side. So iron has 2, right? We have 2 of that element. And our goal is to balance these because the law of conservation of mass would state that nothing can be lost, nothing can be destroyed. Okay, so we have to account for everything in the reactants and the product. So basically, you got to have equal numbers of each element on both sides. That is the goal of balancing a chemical equation. So iron has 2, oxygen has 3, carbon has 1. On the product side, right, this would be P for products. This would be R for reactants. We have 1 iron, right? Because that still counts as 1, just because there's nothing there. We have 1 carbon, right? Because that 2 only goes to oxygen. We have 2 oxygen. So right now, if we look across the board here, we have 2 iron on one side and 1 on the other. That's a problem. We have 3 oxygen on one side, 2 on the other. These all have to balance out. Now, there are subscripts and there are also coefficients. We cannot change what we are given here, okay? But we can change how many of each of these compounds and these elements that we put together so that we have an equal reaction. So if iron has Fe2 here, right, we have 2 of them here and we have 1 here. What I'm going to do is I'm going to go in and I'm going to basically put a 2 in front of them. I'm going to try and do a different color here. I'm going to go like this. Do not like that, but that'll work. So we have a 2 here. And by doing that, we now have 2 iron molecules, okay? So this 2 is called a coefficient. It applies directly to this element, all right? Now, those are both equal. Great, awesome. Are we done yet? The answer is no. We have 3 oxygen here and 2 here. So this is where things get a little bit tricky. We have to look at how we can make things equal. Now, 2 and 3 both go neatly into 6, okay? So if I wanted to get this to 6, I would have to put a 3 in front of it. But I can't put a 3 here. That's a subscript. I can only put a coefficient in front of all of these elements or compounds, okay? You'll notice on your worksheet that we only give you a blank to change this. This is the only thing you can adjust. So if I put a 3 here, try and do this as cleanly as possible. Not bad. This 3 then gets actually distributed to both. So my carbon now becomes 3, right? Because 3 times 1 is 3. 3 times 2 is 6. So now my oxygen becomes 6. Now, we've messed a bunch of stuff up here, but that's okay. All right, that's perfectly fine. Now we got to come back here. In order to get that to 6, we need to multiply this by 2. And I know you're already looking at things like, what the heck is going on? But it's going to be okay. That changes that to a 6. Oftentimes, when you adjust things, you have to go back and readjust, and that's fine. Now, this 2, this coefficient, has to go to both. So unfortunately, this becomes a 4, which is an easy fix. But now we have 4, 6, 1, which needs to match up over here. So if I want to match this 4 and this 4, I'm going to actually have to go back here. I'm going to have to do a little quick erasing here. Let me get my eraser out. Hopefully I don't do too much damage. That didn't end well. We'll back that out one more time. Eraser, eraser. Here's what we're going to do. We're just going to make it a 4, unless I can go outline to white. Anyways, sorry, technical difficulties. I'll go back to my pen. We're just going to make this a 4. It's really bad 4. My apologies. There we go. So now that becomes 4 instead of 2. Now we have one more issue. We got to get our carbon straight. But since carbon's alone, I just need to get that to a 3. All I got to do here is put a 3 in. And now this is happy. So this would be considered a balanced chemical equation. A little tricky. I would say this is pretty much a medium strength problem. It's kind of difficult. But if you wanted this reaction to take place, you'd need 2 iron oxide, 3 carbon to react and yield 4 iron and 3 carbon dioxide. So 2, 3, 4, 3 would give you a balanced chemical equation. So this T-chart can help. If for some reason you go too far, you always want to check to see if there is a least common denominator between all of your coefficients. 2, 3, 4, 3, there is not a common denominator. So you know that this is then simplified and this is a correct answer. Let's say, for instance, this was 2, 4, 4, 2. Well, then, yes, we would have a common denominator. We'd have to divide everything by 2, and you get 1, 2, 2, 1. But in this case, it is all equal. You have balanced a chemical equation, and you've done a pretty tough one here. So your goal today is to practice this, try and get that first page done, and from there, you should be able to make it happen. So good luck. If you have questions, talk to your science teacher, and we'll catch you later. Thanks.